take-home test. It's a question. I can do
Okay, can I have everybody's attention? I know we have some very important matters to figure out with Spencer's mom. It's very important. I just heard him suggesting those whole things over there.
Did I just get roasted?
Yes, and AJ kind of gave himself a backhanded compliment because he said, "Oh yay, I got 100." I never get 100 on the first try. So there are different things going on in different places, but I do want to make sure that we go through today's quiz, that we talk about select homework questions. I didn't do the answers to all of them, but I did answers to a good chunk of them, particularly the ones of recent work. And then we got to get going on today's lesson, round 2 on exponential functions. So, Spencer, if you would kill the lights, please.
Oh my God, I
You hate yourself? You're eminently likable. You should not hate yourself. Yes? Show it tomorrow. Yep, absolutely. Okay. Can I have everybody's head in the game, please? Okay. So let's take a look at the first question. First off, you can tell by the font that these are all old Regents questions. Okay? So this is very much the level of question that you're going to be expected to get right on your Regents exam. The function h of x or h of t or whatever is negative 16t squared plus 144 represents the height at any particular point in time. What's a realistic domain? The input is time, guys. Can you possibly have negative time? No. So 1 and 4 are out. So then it comes down to, is it choice 2 or 3? When is the last time somebody threw an object, dropped an object, whatever, and it stayed in the air for 144 seconds?
It's hollow.
Yeah, basically that's it. So therefore, choice 2 is the correct answer for the first one. Okay, number 2. Too many people got this wrong, and I'm kind of glad we're reviewing it here. So let's make sure everybody's head's in the game on this, okay? If A equals that trinomial and B equals this trinomial, then A minus B, which means you're going to take the first trinomial, there it is, 3x squared plus 5x minus 4, subtract the second trinomial, and we think there's really a little 1 in front of the package, so I have to distribute the negative 1. That changes every sign. Do you remember how earlier in the year when we did this, I said to you that, head in the game. Earlier in the year we did this, and I said that my experience is, for whatever reason, if kids do not write out this step, if you either stack it vertically, or if you just try to do it in your head, you are by far I mean upwards of 7 to 10 times more likely to get this wrong than if you just write it where you have the first term, minus sign, second term, and then distribute the negative 1 to all 3 terms, and show the changing of the signs. If you do that, you're almost always going to get it right. Always remember to change the first sign. That is one that kids, for whatever reason, do forget to change. And then it's combined like terms. 3x squared and 2x squared is 5x squared. 5x's and 9x's are 14x's. And negative 4 and negative 7 is negative 11. So choice 4 is the correct answer. Okay? Now we get to number 3. And is this an exponential function or an arithmetic or linear function? How do you tell the difference between an exponential and a linear function? Oh, these crickets are not good. The silence is definitely not a good thing. Listen very carefully. You need to remember this. This will be on your Regents somewhere. It will be on your next test in multiple places. Linear functions have a constant rate of change, which means that they go up or down by the same amount over and over again. They are arithmetic, so to speak. Exponential or geometric. Geometric rates of change are not consistent. They are either going up by ever-increasing amounts or going down by ever-increasing amounts. So in this case, they're always going up by about 80. So that makes it linear. And because it's going up, it's a positive rate of change. So therefore, it is choice 2. Now, be prepared. I can change the numbers in the table tomorrow, and I can make them go down by a certain amount every time, then it would be linear with a negative rate of change. I could make it multiply by 1.5, like I could go 380, 470, I don't know, what's next, 595, just constantly multiplying it by 1.5, then it would be exponential. I could divide it by half. I could go 380, 190, 95, 47, 50. That would be exponential with a negative rate of change. Okay? So if it goes up or down by the same amount over and over again, and in this case, every one of them is just about 80, that's linear. If it's not a consistent amount, then it is either exponential, possibly quadratic, but for the most part, it's going to be exponential. All right. And last but not least, this is the material we've been working on lately. It is the material that we covered in class the last couple days on Thursday, and then we're also going to cover it today. So I expected this to be a question that you had difficulty with, and I was using it as a springboard into today's lesson. The value of a car purchased for $20,000 decreases. Does decrease mean go up or down? Down. So if you take a look at this, choice 4 is out right away, because if it's decreasing, how could it possibly go up, right? At a rate of 12% per year. So our function is always the initial amount, and over here, I should have written this down, and I didn't, I apologize. It's always 1 plus or minus the percent increase or decrease. What's the percent decrease this year, or in this function? 12%. So what's 1 minus 0.12? 0.88. That's where the 0.88 comes from, okay? And then it says 3 years later, so it's to the third power. And if you just punch that into your calculator, bam, out pops the answer, 13,629.44. Yes?
When do you know to subtract the 1 minus point?
Keyword decrease.
Okay.
Decrease means subtract it, increase, add it.
So, but for the rate of change one, I mean, not the rate of change, the
Bless you.
interest rate one, we just.
Interest rates are going into the bank account, so it's being added in.
Oh.
Okay? Yeah, like I said, I expected you to struggle with this one. I'm not worried about it in the least. Guys, what's the purpose of the first quiz? Show you what you know, show you what you don't know. Fail is a little strong. To show you what you don't know. Now you can go home tonight, and as you approach the homework, you have an idea of where you need to put your attention so that you don't repeat these mistakes. If you do that, you're doing fine. That's the whole purpose of the first one. Tomorrow and Wednesday, I expect to see really good grades. I couldn't care less what you got on this today. It makes no difference to me. What matters to me is that right here and right now, you had a couple of aha moments where you say, oh, I didn't realize that. For instance, the word decrease, meaning to go down. That's an aha moment. Another aha moment might be, and listen, when I come in to teach, I have the best of intentions, and I do my best every day, but that doesn't mean I get the point across as clearly as I should every day. Some days I just don't. It's not my, well, I guess maybe it's my fault, but I try. It just doesn't work out. And then I come back to it through quizzes, through do-its, through homeworks, and we emphasize the points and then make certain things clear. Now, I thought that I had mentioned many times this year that a linear function has a constant rate of change. Apparently, I didn't make that point clear enough because way too many people missed number 3. Or I made it and it's been a while and you forgot. Whatever, I don't care. It doesn't make a difference to me why. It just matters that it doesn't happen again. So we emphasized it now, and then tomorrow I don't expect to see many people make that mistake. In all honesty, if people get number 3 or 4 wrong tomorrow, in my opinion, it's because they didn't do their work tonight. Or a stupid mistake. Because this is not hard stuff. All right, and maybe it could be completely my fault. Number 4 is my fault. It's not your fault. It's my fault. I didn't do any decrease questions. So, but now you should be good for tomorrow. So, all right, now let's go to the homework. All right, so I didn't do all the questions, but I didn't do any on the bottom of the first page there with the quadratics. We've done a lot of those lately. I wanted to save a little time today. Here's completing the square one and a graphing lines one. And then, Janelle, I would call your attention to number 4, because this one is one where it's increasing, and you'll notice I did 1 plus the 1.8%. Okay, see the difference? Decrease, I went down. Increase, I went up. Okay? You always add or subtract from 1. And then the question is it increase or decrease? Increase, go up, add, decrease, subtract. All right, number 5, I as we told you to do, don't do any add, subtraction or anything. Get rid of all of the variables, and there are your radicals done for you. Okay, any issues? Okay, let's go to the next page. A little bit more sequences stuff. I think by now we should be getting pretty comfortable with questions like number 6. Right? I think we should be looking at it going, yeah, I got this. This is pretty good. I'm getting in the comfort range here. It can take a week, but at this point we should be there. Of course, you can change a sub n plus 1 and a sub n for a sub n and a sub n minus 1. They're interchangeable terms. Think of them as previous and the new term and the previous term. Okay. We had already done number 8. So, but these 2 pieces we were supposed to do here, so I have those marked down. Okay. I think number 9 is pretty straightforward. Number 9 should be very comfortable at this point in time, right? Okay. Next up. All right, so on this one, we did a lot of questions like this earlier in the year. How do I know it's going to be a maximum? God bless, because any quadratic that starts with a negative term in the front is always a frowny face, upside down one. Most of this is review. Find the maximum height. It's 144. It's at 2 seconds. I did that by putting it in, God bless, by putting it into the y equals function and looking at the table. Okay? It's increasing over the interval from 0 to 2. It is decreasing from 2 to 5. And evaluate h of 0. H of 0 is 80, and that tells you the height from which the ball is thrown or dropped or whatever they say in the problem. Okay? Questions? All right. Last page of, oh, this is to do it. Going over. Ready? For the first term, it's geometric for sure because you're going, notice, Janelle, here's a question that we actually did, I think, this very question before. And notice it says decreases.
Yeah.
And I went from 1 down to 2/3. Because remember we said that if you use up, if 1/3 decays, what amount remains? It's 2/3. Okay, so 2/3 is my coefficient here. And the new term is 2/3 of the previous term. And the first term is 1452. And then over here, we are increasing. Appreciate means to go up, to increase, at 5.2% per year. So that makes it 1.052. 1 plus 5.2%. 5.2% must be a decimal. So it's 1.052. And n is the number of years. You can use t, doesn't make any difference. And if you just put this into the table, I just scrolled through the table until I hit 3,000. And that was at 36 years. Okay? Any questions? All right. So you have an idea of what it is that we have on that work. And what I would be doing if I were you is making little notations on my work, my homework, and so on and so forth, that I know I need to look at tonight before I start the homework. And if we do that, we're in good shape. All right, so now we're just going to apply the kind of work that we've been going over the last couple of days and, you know, just work it and exercise it and stretch our brains a little bit. Bless you. We're not going over anything new. We're taking what it is we've discussed, namely exponential functions, and we are going to take those exponential functions and use them. And I'm going to do that as soon as I find my awesome magic wand ready. Here it is. Whoa. All right. So, Callie and Joe are examining the population data in the graphs below for a history report. Their comments are as follows. Callie, it looks like the US population grew at about the same amount as the world population, but that can't be right, can it? Joe, well, I don't think they grew by the same amount, but they sure grew at the same rate. Let's look at the slopes. Okay, so first off, can we see that the graphs look roughly the same? Okay. But if we look, what do you notice is different about the graphs? Spencer?
Y scale.
Yeah, the scale is definitely different. Over here, we're going up by, and this is in terms of millions, 1,000 million, better known as a billion, 2,000, 3,000, so on and so forth, and this is in millions, 50 to 100 to 150. Notice this is going up by 50s. What is this going up by? 1,000. So when Joe says that the rates of change are the same, what do you think about what Joe said?
That's not true.
Yeah, that's ridiculous. It's completely absurd. Yeah, they look like they're going up by about the same amount, but in this case, you're only going up by 50. Or, and this is half of one, so you're going up by 25 million. Over here, yeah, you're going up by half of one, but that's 500 billion. Oh, I'm sorry, 500 million. So 500 million versus 25 million, it's definitely not the same. Is Callie's observation correct? Callie says it grew by the same amount. No, we just discussed they're completely different amounts. Joe's observation correct? No, the rate of change is not the same either, and that's in large part because they grew by different amounts. Use the world population to estimate the percent of increase from 1950 to 2000. Okay, percent of increase from 1950, which is about here, to 2000, which is about here. Now, if you want to do percent of increase, this is a review topic from years past. Percent is always done this way. Percent over 100 equals part over whole. Are you remembering that?
Yes.
Right? They don't put a lot of percent on the regions, but sometimes they put some on. And it's really not part of this course. You're supposed to know this from years past. It wants the percent, so that's n over 100. Now, the part is how much it went up. If it went from 150 to 275, how much did it go up?
125.
125. Out of the whole, which is the initial amount, which is 150. So if we do a little cross multiplying here, I get 150n equals 12,500. Could somebody do that division and tell me what you get? It should be like 83% or so. 12500 divided by 150.
83.3 repeating.
Good, okay, so we'll go 83.3 repeating percent because it goes in the percent place. All right, what was the next question? Because I don't want to lose the graph here.
Now, use the U.S. population graph to compute the percent increase in the U.S. population for the same time period.
Oh, okay, we did the US. I guess we were supposed to do the world. Let's go over here and do the world. All right, the world would go from 2,500 to 6,000. That's up 3,500. So if I'm going to go up 3,500 out of 2,500, because then and it'll be n over 100. If I cross multiply, I'm going to get 35 and 4 zeros divided by 2,500. So what do I get? 3,500, no, 35 followed by 4 zeros.
140.
Is it 140? Okay, so n equals 140%. So the world's gone up by 140 and the US has gone up by 83.3 repeating. Okay, what do we have next?
How is the percent?
Oh, and by the way, I did this very quickly. I apologize. Look, how I did this, how I knew the rate of change. This is the point 1950, which is the first year, okay? So I'll call that 0. And this is 2,500. And then I did this point, which is 50 years later, and that would be at 6,000. So I did the percent over 100, and then I used these two numbers, which goes from 2,500 to 6,000. So that's how I was able to do it, by looking at the values on the graph. I sloughed right over that, I should have mentioned it. Janelle, I'm sorry, what was the next one?
Oh, I was gonna say, how does the percent increase of the world population compare to the US population over the same time period?
Clearly greater.
Huh?
Clearly it's greater.
1950 to 2000?
Right, clearly it's greater, okay? Anything else?
Question and a half.
I'm sorry?
That was question E. Next question.
And that's the last one?
Then there's question D.
And what does that say?
What do you have to the graphs above seem, do the graphs above seem to indicate linear or exponential population?
What do you think, linear or exponential?
Probably.
Linear, right? What does an exponential graph look like?
Looks like a,
Okay, it might be a short piece of an exponential graph, but it tends to look more linear than exponential. Look, it doesn't mean it is. Population is very much exponential. But they've cut a piece out, like let's say from here to here. Doesn't that little piece of exponential look linear? But if you take the whole thing over time, the population is always exponential. Okay.
wait, NG.
Write an explicit formula for a sequence that models the world population based on the information of the graph. All right, so an explicit formula would be, let me see if I can remember all this stuff. F of n is equal to, what was the first number on the graph?
which one, the world population?
Yeah,
2,500.
and this is in millions, 2,500 times, it looks linear, so we're going with linear on that. Plus, and what percent did it go up by? 140? So it would be 2,500. I'm confusing let me get rid of this here. I was going with recursive versus the other one. Let's see here. F of n is equal to the first term, which is 2,500, plus 1.4 times n minus 1. Because it's going up 140%, which is 1.4. And then n minus 1 because we have to subtract 1 because we don't need to get to it for the first year. All right, take a look at example 2. What does that look like? Linear or exponential? Exponential, and it's the same exact data. What's the difference in the data? They went further back in time. See, the 1950 to 200 was the piece from here to here. Doesn't that piece look linear?
Yep.
Yes, but within the whole graph, the entire graph is exponential. Okay? So it's similar in the sense that this piece is the same piece of data, but it's different that they go over a greater length of time here. What's the behavior of the graph from 1950 to 2000 match? We already said that it matches. All right, very quickly, I just want to remind you, when we deal with exponential increase or decrease, it's always the initial amount, call it a sub 0, times 1, plus or minus the percent to the time. You go up or down. Which one goes down, increase or decrease?
Decrease.
Decrease. Which one goes up? Increase. Very good. We have another day on this tomorrow. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Adios, amigos y amigas. Cheerio. Salutions. Kedafis. Shalom. Sayonara.